So we have been discussing about image formation by spherical mirrors, that is concave mirrors. Now let us see how image will be formed by using convex mirror. So image formation by convex mirrors. Let us see this. First one, position of the object, ray diagram, next size of the position of the image, nature of the image. Or we can write size and nature of the image. That is size and nature of the image. So let us see the first position of the image, that is at infinite distance. When the object is at infinite distance, let us see where will be the position of the image. First one, at infinity. So when the object is at infinite distance, let us see how will be the ray diagram. So if the reflecting surface is curved outward, we call that as convex mirror. So this is pole, let it be principal focus, this is center of curvature, and the line passing through these points, we call that as principal axis. Now consider that the rays of light which are coming from infinite distance are falling on the convex mirror parallelly. So these parallel rays of light, so after reflection, they diverge in such a way that they are coming out from the principal focus. So they diverges away. So that is the reason why we call convex mirror as diverging mirror, because when the light falls on the convex mirror, they diverge away, but it appears to be that it is coming from principal focus. So let us consider another ray. So when these extensions of reflected rays, these are the reflected, these two are incident rays and these two are reflected rays. When we are extending these reflected rays are intersecting at a point. That point we call that as principal focus. So image will be formed at principal focus and the size of the image is point sized image. Now let us see what will be the position of the image now. Position of the image is at F. Then what is size and nature of the image? Size is highly diminished or point sized. Highly diminished or point sized image. Highly diminished and point sized image is formed. So this is for the object which is at infinite distance. Now next position is anywhere between infinite distance and center of curvature. So anywhere between infinity and pole of the mirror. So for different positions, here we are considering these rays are coming from infinite distance. Now when the object is between infinite distance and the pole of this mirror, so let us see the characteristics of the image that are formed. Now consider another convex mirror. Let this be pole, principal focus, center of curvature, and the line passing through is principal axis. Now let this be the position of the object. Now consider a parallel ray. So it diverges in such a way that it is coming from principal focus. Now consider another ray such that it is moving through center of curvature. So when the light ray is passing through center of curvature acts as, the line that is drawn from center of curvature acts as normal. So when this ray is passing through center of curvature, it comes back in the same path. So this will be the incident ray, and the reflected ray will also be the same. As it is incidenting normally, it comes back in the same path. So these two rays, extensions of these two rays are intersecting at one point, and this point gives us image. And this will be the size of the image. So if we take this as AB, this will be A dash B dash. So if the size of the object is AB, size of the image is A dash B dash. Now let us see the position of the image. Where is the position of the image? Position of the image is between pole and principal focus, that is P and F. Let us see this. Position of the image is between P and F, between pole and principal focus. Now size and nature. Let us see the size of this. Size of the object is greater when compared to the size of the image. So then the image that is formed is diminished image. So diminished image. And whether it is real or virtual, see here the image is formed because of extensions of reflected rays. So the image that is formed is virtual. So virtual. Next, whether it is erected or inverted, when the image is below the principal axis, we call that as inverted image. If it is above the principal axis, we call that as erected image. So virtual, erected, and diminished image. So what are the characteristics now? Virtual image is formed, erected image is formed, and the image of, size of the image is less when compared to the size of the object. So these two are the positions for which we are drawing ray diagrams, or we will see the position of the image that are formed. So irrespective of concave mirror, in concave mirror we have 6 different positions, but here we have only 2 positions. The reason is wherever we keep the object before a convex mirror, so irrespective of the position, so between pole and infinite distance, we get the same characteristics and same size of them. For example, if we observe the rear view mirror of our bikes or cars, our vehicles, so the mirrors that are used is convex mirror. Wherever the object, we will find the size of the image as a fixed one. So that is diminished image. So whether lorry is coming or the person is standing behind our vehicle, we will get the image as a fixed size, that is a diminished size. So that is an example for this. Okay, now, and the other topic which we come across in this is mirror formula. Mirror formula and sign convention rules. Let us see that. Mirror formula is used to find the distance between, if object distance is given and principal focus is given, we can find the image distance, or the size of the image or nature of the image can be calculated by using mirror formula. Let us see what is mirror formula and what are the rules which we come across while solving problems with that. So mirror formula. So mirror formula. Mirror formula gives the relation between image distance, object distance, and principal focus. So let us see the object distance. In mirrors, object distance is represented by letter U, and image distance is denoted with the letter V, and principal focus or focal length is denoted with the letter small f. So the relation between these three, we call that as mirror formula, and the formula is 1 by f is equal to 1 by u plus 1 by v. So we call this as mirror formula, that is focal length, reciprocal of focal length is equal to reciprocal of object distance plus reciprocal of image distance. So if we know the value of, for example, if the object distance and focal length of the mirror is known, then we can find the distance at which the image can be formed. So by using this formula, we have to remember certain rules. We call them as sign convention rules or Cartesian rules. Let us see what are those rules. Sign convention rules. Sign convention rules. See, let us consider this as a concave mirror, pole, and this principal axis. So first rule is all the measurements has to be taken from pole. So that means we have to take this as reference point, and from this point we will measure whether the object is this side or this side. So all the measurements has to be taken from pole. So all the measurements has to be taken from pole. Now, for example, if this is a concave mirror and the object is over here, so we will be measuring this from this side. And what is the direction of incident ray? Incident ray will be in this direction. So both of these are opposite in direction. So when the measurement is opposite to the direction of incident ray, we take that as negative. Okay. So if the measurement is in the direction of incident ray, then we will take that as positive. For example, in concave mirror, incident ray direction will be in this. That is opposite to this. So when we take a convex mirror, for example, if we take any object, then that will also be negative. So for example, focal length, let this be center of curvature and this is principal focus. So when measuring center of curvature, this is radius of curvature, this is center of curvature, and the distance between these 2 points, we call that as radius of curvature. Radius of curvature also will be in the direction opposite to the incident ray. So almost f value, principal focal length. So the distance between principal focus and pole, we call that as focal length. So that is also in the opposite direction of incident ray. So whatever, for all for different positions of object, we will get V value. V value is always this side. So for except for sixth position, that is when the object is between F and P, we will get the image behind the mirror. So for the remaining positions, we will get inverted image on this side. So for those remaining 5 values, we will get V as a negative. And this side, when for the sixth position, when the image is this side, we will be measuring from here, and the incident ray is in this direction, and also the measurement which we are taking is also in the same direction. At that time, we will get V as positive. For the remaining 5 conditions, we will get V as negative. So these are the sign convention rules. And also other one is when the object is above the principal axis, we will take that as positive value, and when it is below the principal axis, we will take that as a negative value. So first one is all the measurements has to be taken from pole, and the second one is so the direction opposite to incident ray. Incident rays is taken as negative. So if the direction of the measurement is in the same direction as that of incident rays, we will take that as positive. So if it is in the same direction, we will take that as positive value. If it is opposite in direction, we will take that as negative. And in terms of this principal axis, above the principal axis, we will take that as positive value, and below the principal axis, we will take that as negative value. Okay. So while doing numerical problems, we will consider these sign convention rules while using this formula, mirror formula, 1 by f is equal to 1 by u plus 1 by v. And the last topic from this is magnification. Let us see what is magnification and what is formula for finding magnification. So magnification is denoted with the letter small m. It shows that by how much ratio the value, the size of the image or object is, whether it is increasing or decreasing by certain value. That value we call that as magnification. For example, magnification, if the size of the object and size of the image is same, So when the object is at center of curvature, the object distance and size of the object and size of the image will be same. At that time, we will get that as same value and they get cancelled and we will get that as 1. Magnification is 1. When magnification is 1, then the size of the image and size of the object will be same. Let us see the formula for finding magnification. Magnification, m is equal to height of the image, hi by height of the object, h naught. So m is equal to hi by h naught. So in terms of image distance and object distance, this can be written as minus v by u. So this is formula for finding magnification. Okay, m is equal to hi by h naught, that is equal to minus v by u. So these are the topics which we come across in reflection of light. So what have we discussed till now? We have seen what is reflection, types of reflection and loss of reflection, then plane mirrors, how image will be formed in plane mirrors and characteristics of images that are formed in a plane mirror. Next, coming to spherical mirrors, how image will be formed by using spherical mirrors. That is, first one is concave mirrors and their ray diagrams, and image formation in convex mirrors and their ray diagrams. Next one, mirror formula and the sign convention rules and magnification. So these are the topics which we come across in reflection of light. Thank you.